Morning. Before we get started, quick question. Uh, I want to understand what everybody's background is. Like, so how many people have already worked on serverless before? Show of hands. All right, cool. How many people have heard of serverless? All right, cool. Okay, that's a good mix. So the goal is to talk a little bit about what problems serverless paradigm solves. And I wanted to show you this new framework. Well, it's not new, it's been flying under the radar. Show you some examples of how a good DX for a developer experience for building serverless applications looks like. Um, Quick intro about me. Everybody calls me GP. GP stands for Ganesh Prasannah. Every team that I've been a part of, there were lots of Ganesh in the team. So it started off as a way to differentiate, but the name stuck. Everybody calls me GP now. My in-laws call me GP, so that stuck. My background is a mix of everything. I started off working on mainframes. Then I've been working on UI UX for a long time, backend for a long time, which includes serverless, and then platform engineering and distributed systems for a long time. So right now at I'm an operability consultant. What we define as operability is a mix of DevOps, SRE, performance engineering, and platform engineering. That's the problems we solve today. Um, all right, quick intro about serverless. And please feel free to stop me anywhere when you have questions and if you want something to add, right? So all of the cool things about serverless is one, cost savings. That's one of the things that people would talk about a lot, which is instead of provisioning a server and have it running 24/7, what serverless does is you give it a request, uh, a new small app is spun up, it responds to the request, does all of the job it needs to do, and then it goes back to sleep. So that time you save a lot on running costs, right? So that's very useful. Second, massive scalability. Again, the biggest promise for serverless is it can instantly scale to 1,000 requests. What Google calls it planet scale. The idea is, let's say you're building an e-commerce website. Every day you get about 100 requests, orders, say, right? So 100 serverless instances would spin up, respond to the requests, go back to sleep. Suddenly, let's say you are having a Diwali sale, and that 100 becomes a million, right? The promise of serverless is you don't have to make any change in your provisioning, in your infra. It would automatically scale up for that many requests, go back to sleep. In a traditional setup, let's say you're running EC2 or Fargate or whatever, even though you do have auto scaling controls available, you would still have to turn the knobs. You will have to say, hey, I expect a million today. Set the max number of instances in the scaling group to a million. You will have to set that up. And then there's also a cost involved in bringing up a new box in whatever clustering mechanism you have, right? The other advantage is productivity. So in a traditional setup, again, you will have to worry about how this will be deployed. If it's a Python app, do I have to set up GUnicorn? Do I have to set up WSGI? Do I have to, I mean, you will also have to worry about parsing individual requests on a lower level, but on serverless, a lot of that is abstracted out. So when you're writing a Lambda function, you would generally just expect an object, right? Not a HTTP request. So a lot of the things like parsing a HTTP header, etc., routing, all of that is sort of offloaded. So it's a simpler mental model when you're building serverless. Now, not everything is rosy. It does have its own problems. So I also just wanted to point that out. It might serverless is not a magic silver bullet. It might not fit every single use case. So some of the not so cool parts about serverless is there's a cold start problem. If you remember, I said anytime there's a sudden spike in the requests, new serverless instances are spun up, right? It still takes some time. Not as bad as EC2 or Fargate or traditional box. It still takes some time. So it's not magical yet. There's a few solutions here and there, but it's not perfect yet. We're getting there. The other thing is it's not super suitable for stateful workloads. Now, let's say you have like a cron job. right? Or it's a request or it's a sync job or a batch job that runs for 30 minutes, right? It's quite difficult to run it in serverless because serverless are short-lived. I think on AWS the max is 15 minutes now, or 30 minutes, 15 minutes, right? So there's some improvements there, but it's not perfect, right? For every single use case. Third is also vendor lock-in. Now, just how AWS has Lambda, Azure has function apps. So all of these are slightly different. So when you build something, when you choose your framework, when you write code, you are still making assumptions that, hey, this is running in a Lambda. So is it fully portable? Not really, if that's important to you, right? So it's a little bit of pros and cons. We'll see more about how this is useful and where these things fit correctly. Any questions so far? All right, we'll move. So serverless development, I know there were a bunch of people who said, hey, I've worked on serverless, right? Can you guys tell me what frameworks you've used for that? Lambdas. Okay. Anything else? Okay. No, I mean, not the infra bit, but like what framework or tool you use to write code for Lambda functions. Okay. And was there any specific frameworks you folks used? No, this is useful. When you said Express, it's useful. Okay. So, all right. Anything else? Serverless, where you write the serverless.yaml. Yes. Okay. All right. So, like that. So, serverless.yaml, serverless is also a framework. It's the name's a little confusing, but there's a framework which makes some of the things easy for you. For example, you said Express, right? You're still writing your code, but there's a bunch of steps where you have to compile it, build it, push it to the actual Lambda, hit it, and only then you can be sure that okay, it's working fine, right? So that's what I think is like the part that everybody hates, right? You can't run it locally, make sure it works fine. If it's a simple Lambda function, it's returning a hello world. Some of these frameworks make it easy for you to run it locally. But let's say it talks to SQS or RDS, right? And imagine then those are running inside your VPC. It becomes impossible to test this locally, right? So this is one of the biggest pain points I think in serverless development, unlike traditional applications. So it's almost impossible to test locally for a lot of use cases, right? So a lot of these frameworks have some of these problems. One is no quick feedback, which is what I spoke about. It's quite difficult to run them locally. So again, the development cycle is big. You have to build it, compile it, push it to prod, deploy, test there, come back, right? Second is poor emulators. Some of them give you a local emulator to solve problem number one, right? But again, they're not perfect. So there's a framework called local stack. It gives you a local copy of S3, local copy of SQS. They've sort of reverse engineered everything and give you local copies so that you can run them all locally. But they're not perfect. There's still problems. Like for example, let's say you're on AWS and you're writing logic to write logs in a specific format to CloudWatch. Now you can't test that locally again, right? So emulators are almost never a good solution here. They're a stopgap. Three is, I would say, it's also quite a big problem, but depends on how teams are structured. So the third problem is you cannot manage other bits of your infra. Now, 9 times out of 10, when you're building an application, it's probably talking to a database, right? Now, in serverless, all of these popular frameworks, they let you only write the code for the function itself. Now, let's say it was talking to a DB. Where will the DB come from, right? So that becomes the responsibility for another team. That means now you are building an assumption under the assumption that, okay, it's managed by somebody else. Then that becomes problems because you're creating silos in your teams. So you will tomorrow say, hey, I've written a Lambda function. I tested it in my local database. It works. It goes to production, breaks for some reason. I don't know. It could be because you tested on the wrong version of Postgres, right? Stuff like that happens, right? So this is another problem. Fourth is always language lock-in. almost every single framework is written only for one specific language or a runtime. So let's say you start with serverless, right? And it's Node.js, right? So it's Node. Now tomorrow somebody says, hey, no, I want to change this to Python for whatever reason, right? You're stuck. You can't really take that code and do that. It's a smaller problem, but still a problem. Uh, In reality, nobody's changing languages midway through a project, right? But it's still something to think about. So now I just wanted to talk to you about how this framework that can solve a lot of these problems for you, and it's SST. Quick question, show of hands, how many people have heard of SST? Okay, just one. Which is why we wanted to do this, because SST has been flying under the radar for too long, but it's a brilliant piece of software. I'll quickly just walk you through some of the cool things it does, and we'll jump to a demo. If you folks have more questions, I'll show you folks and walk you through some of the changes. We'll do some cool stuff with the demo. Yeah. So SST is so what it does at its core, and what makes it so simple is they use, so every AWS account comes with a IoT framework for Internet of Things devices. It's a low latency WebSocket that you can build on top of all of that. So you install SST. SST creates a CloudFormation stack on your own cloud, and then what it does is when you run a Lambda, it creates a local socket stub and it forwards connections from your local computer to AWS. Now, this means when you create a Lambda and you run it, it actually runs on the AWS infra, which means you're testing a real Lambda. But things like console log shows up on your computer because the socket intercepts and stubs the console stuff. So you get full actual development. Now, let's say you change some stuff, you hit Command S, you save, the incremental patch is sent over the socket, instantly deployed. So you technically get hot reloading, but for Lambdas. And then it does a lot more cool stuff. There's no emulators. They have the environment stuff. So you can do things like npm dev. It'll create a stage called dev. You finish testing, you're happy. Then you just do npx deploy -- stage prod. It goes to prod directly. So everybody gets their own development environment. And remember, serverless is cheap. So you can have 100 people creating their own environments, still cheap, right? And then finally, when you deploy, you can just stage it to prod, and it goes to prod. So the life cycle, the DX is amazing. Next is provisioning infra. So SST is built on top of CDK, AWS CDK. And what CDK is a bunch of constructs that are auto-generated from the AWS infra. So let's say they bring a brand new product tomorrow, right? They will auto-generate code for you, and it's immediately available in CDK. So now in SST, they've created nice wrappers for most of the common stuff that you want to use: queues, databases, Fargate clusters, uh, notifications, emails, cron jobs. They have higher level stuff for all of this. So 99% of your problem statement is already solved. But let's say there's this rare product in AWS that you want to use, you can drop down to CDK and then use that. So it's seamless. So what this gives you is you can write code for every single infra piece. You want a database in your application, you want a bunch of SQS queues in your application, you write all that in code. That means you own the full application end to end. You get visibility into what everything is. So it's a much nicer model. There's no CI pipelines for Terraform, for infra, nothing. You own everything. So it's a radical new way of looking at this. So the demo that we're going to do for SST is using slightly older version. They've actually improved it recently in the last 2 months. They've rewritten the core framework to instead use Pulumi instead of CDK. Pulumi is a framework that's very similar to Terraform in a lot of ways, but it lets you provision infra faster. One of the bottlenecks here in SST and Terraform and most frameworks are they depend on CloudFormation when it comes to AWS. And CloudFormation is always slow, especially when your stack grows and there's a lot of application. They've improved that. We'll probably look at that in a future session, but for now, SST is still pretty good. So I'll do a quick demo. I've built a small application that I wanted to just show you folks and walk you through how you make changes you deploy. Any questions before I start? Yes, please. Um, yes. So the short answer is it depends, right? The longer answer is SST does give, does best practices stuff out of the box. So the IAM roles are restricted, are contained. So technically, I cannot say delete your dev environment. So that way it's secure. But if you're talking about things like SOC 2 compliance or HIPAA compliance or things like that, right? It would it would depend on the use case, and then you would also have to have higher level controls over that. It's specific to the team, but that's where the advantage of using this being built on CDK comes. You can then drop in and say, "Hey, I want." Let's say this is an enterprise environment, right? You would have org level rules that says you can't do this. For example, you will say you can't have CloudWatch logs for more than 3 days, for example, right? How I would imagine you solving this problem if you were using SST is you would have a meta package for SST where you have configured, say, AWS config, and you would have all these rules set up. And then you would distribute that package inside your org and say, don't use SST directly, use this package. It is exposing all of SST, but with additional stuff. Yes. So you can technically pre-package that because SST is built on top of CD. Does that answer your question? Good question. It does only support AWS. That's a single problem. Because AWS is just nicer. I'm sorry if this hurts feelings, but Azure is, I hate it so much. I'm not supposed to say that. I work on Azure as well on my day job, but um, honestly, if you want to build something very, very, very reliable, AWS is the way to go. Yeah. Yeah. So, but it's on their roadmap, but honestly, it's a long way off. And also one of the things that I would say for like a lot of people is there's no realistic way to work around vendor lock-in. You cannot. You cannot write truly portable code of any scale. Honestly, it's difficult. Yes. Yes. So it's always there's going to be stuff that you have to do for your cloud. It's almost difficult. Um, but this reminds me of a nice point. So lambdas also support container images now. So it's even more easy. I think up to 2 GB of size. So you can technically run Docker images also on lambdas. And cool thing, this supports Docker images as well. Um, any other? Yeah. Yeah. Yes. Yes. Yeah. Not SSD. And I'll tell you why SSD did not solve that problem. When you do that, you will eventually end up inventing your own cloud because it's difficult to do, right? But I'll also make one thing clear. When I said you'll receive only an object, uh, the object is technically just the request payload. That doesn't change anything, right? So if you want, you will probably get a second argument in the function that gives you the raw object, and that will have AWS specific stuff. But in most cases, in AWS, for example, the Lambda gets an API gateway in front of it, and it has a bunch of routing rules. So you say, hey, I want this post request with this body, and then the object you receive is just the payload. So technically, that piece of code doesn't have anything specific to AWS. So it still technically works. Does that answer your question? Yes. Yes. So because Lambda had like a 10-year head start, when Lambda came in, no similar offering existed. Right? But because Lambda almost became a standard, just like how S3 has become almost a standard, even though it does not have a spec, it's become like that. So everybody sort of followed the same stuff. So it does work, but not in a truly 100% compatible manner. There's no guarantees because it's not a spec. Does that answer your question? All right. Any other questions? Yes, please. That's what I've been talking about also, Ilman. Yes. 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 No, no simulation. It actually forwards everything to the cloud. Yes. Yeah, you can. Oh, that's a nice point actually. It does support remote debugging as well. So what this does mainly, if I want to say, I can convince you with only one thing, right? If that was the case, I would say the greatest thing about SSD is live reloads and instant feedback, right? Without that, you said Express, you use Express a lot, right? So there's a step of you compile, push it, deploy, wait for it to finish, then hit that request, check, and get feedback. Imagine if none of these steps existed. You were just running locally, you see console log instantly, but it is technically actually running on AWS, right? And imagine if that function was, say, using SQS or RDS. It's impossible to run locally. What do you mean? Yes. Yes. If you're happy with that, I would say go do that, right? But one of the things that I've seen with local stack is that they always have weird corner cases because technically they'll give you a SQS stack. It's an SQS emulator. It's not 100% SQS, right? Because technically it's not SQS. SQS is not open source. So they've reverse engineered it and they built a copy for you. But is it real SQS? Not really, right? So you will always discover weird edge. Second, now you said a local has. I mean, back when I tried local stack, it used to run on Docker and things like that. It looks like it's graduated to K test and everything. That K is something I've explored where okay. We build it, make sure that the solution is working for our use case. That was a specific thing that was not given out of the box, but okay. Still we explored how we can simulate that because whatever the use case you have said, right? Let's say RDS, I was able to run it with the Postgres, and then we can perform the queue actions, and then we can have a consumer. Everything was possible. So that's the reason why I'm trying to process what problem does it really solves. That was the reason behind the question. Yeah, but have I answered your question? Have I convinced you enough? Yeah, maybe okay. The live debugging, yeah, it's okay. I'm convinced. But when we consider it at scale across all the platforms, this is a problem that it is trying to solve only specific to AWS. But you have mentioned that they have a roadmap that is going to come up in the future. Yeah. But for now, I think this is a problem that is existing, but might not be applicable for all different use cases. Is that correct? Yes and no. But I'll also urge you to think about this differently, right? So you said, hey, this doesn't work on AWS, so I don't want to use that, right? Which is a valid concern, right? But 9 times out of 10, nobody's changing a cloud provider ever. Nobody for many years. Most companies that chose Azure in reality, they end up choosing Azure only because they got startup credits from Microsoft. Okay. Honestly, that's it. Otherwise, everybody's going to AWS, right? And then once they go into AWS, you build stuff, it works, right? It's an enormous challenge to move it to any other cloud. Could be some just two simple services, right? Then, but you have to worry about, will it actually work? How do I test? Do I have testing frameworks? How will I transfer my logs? How will I transfer my data without any downtime, right? So everybody's stuck. So if you're on Azure, you're on Azure. SSD will not work for you today, right? But this is more, and I think I don't have the numbers, but like 80% people would use AWS. Right?
I totally agree
Yeah,
with that.
yeah.
What is maybe if we are trying to solve a problem, the problem statement would be generic across all areas. Let's say I'm not thinking about switching from AWS to Azure. Let's say the environment is in Azure by default. Then the SSD will not be applicable over there at all.
100%. Yeah. 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 So, I mean, that's why I also initially gave the disclaimer that it's built only on AWS. But that's the thing with problem. That's the classic problem with software engineering, right? You, in reality, you will have to optimize for the happy path for the 90% of the use case, right? So that's how it is. We can't make everybody happy in everything, right? That's how it is. Any other questions? All right, I will quickly do the demo. Okay. Is the code clear? Can you guys read everything? Sorry, what? Hold on. All right. So, I mean, I don't want to focus on like the package, JSON, contents, and the folder structure and all of that. That's you can figure it out from the documentation. That's the easy part, right? So I'll quickly run this first. I'll show you what's happening, and then we'll walk back and see what this application is doing. Oops. Oh, my AWS credentials are a little old. Give me a second. Everybody close your eyes. All right. So if this is deployed, the very first time and the first time that you run SSD, it takes about a minute because it deploys its own bootstrap stack on CloudFormation. But it's deployed now. Now it's giving me an endpoint. What I've done is this is a simple SQS publisher. You hit this endpoint with some request. It pushes it to SQS, and then there's a consumer that's running that's going to print the messages that it is receiving. Um, all right. Okay. I mean, I hope this is you can see that. So I'm just sending some message. Right. I'm going to send this request now. I'll show you the console also. Right. It's empty. Uh, I've sent the request now. This is actually hitting the API gateway and the Lambda, and I got a response. Now, if you see the console, you can see that the producer function was invoked. You see a console message that says it was produced queued by the producer, and then there's a consumer that's listening to it, and it's received this, right? So this is what is happening, but I'll show you where this actually ran and what this logic is. So this is, what I'll start with stats. So this is the only piece of SST specific code that you will write. So what I've done is I've defined a new stack. So what stack means in SST is uh, it's an encapsulation of all of your code. It's just a container object for all of your pieces of code. That's it. I've created a new queue and I've set up a consumer here, and then I've created a new API. API is a helper in SST for Lambda plus API gateway. That's it. So I've set the functions, and this is the cool part. So you can just write bind queue. So this is how you connect different pieces of infra in your SST code. You can say, hey, this function, this API function, this Lambda function needs access to the queue. So SST will figure out the correct IAM permissions for it. It'll set up, okay, this is the SQS consumer, and it'll set up the permission. This is, again, I'll tell you, is one of the most underrated advantages of building on AWS, because if you've written anything, you've built anything for AWS, the biggest challenge is IAM. Everybody hates IAM. You're constantly fighting IAM. Something breaks, you'll have to go over a lot of Stack Overflow and support requests and all of that to figure it out. Right? So this makes it very, very easy for you. And I've set up a post handler for the producer. This, if you remember, is what is where I sent the request to. And you can add outputs. Uh, Outputs is just, you're defining print me all of these details. So tomorrow I can programmatically get this and send this somewhere. Let's say there's another piece of infra that wants to use this as a variable, right? This gets defined. It's programmatically available. That's it. Now let's look at the producer. And if you see this, this is technically, this code is not related to SST at all. This is how you would generally write a producer for a Lambda function producer for SQL. Right? Simple, you're reading the body, and I'm reading it as, parsing it as JSON. Um, and I'm just sending this to SQS, and I've written a console log, and I've written this body, which is status successful. If you remember, status successful is the response from here. So here, there's absolutely almost no code from SST except for the queue part, but we've already bound that, so it's okay. Right? So this is all the producer does. Second, there's a consumer, and then it's just printing whatever messages you got. Again, this is just from AWS Lambda. There's no SST code here, right? Now, when I sent the request, you saw that the response came immediately. Right? It was fast, instant, and you got it on console log. So now you are technically able to test this everything locally, instant feedback. Right? Now, let's say I want to make some change here. Right? I'm making this change. Now, without something like SST, what would happen here is you would again have to build this, push this to Lambda, wait for it to finish deploying, then hit that request, then go back to CloudWatch, see the logs, verify that this change was made. Right? Now I'm saving this. Right? If you watch my terminal, it just says done and it's built. Right? The incremental patch is already transported to actual lambda. Right? Now I'm sending a request again. Done. If you see this, you can see my change happening already. Right? Now, some of you could say, hey, what if all of this is just running locally, right? Because it looks pretty fast. It doesn't look like it went to AWS, right? I'll quickly verify this to you. Uh, this is my Lambda function. All right. So you can see that it was actually invoked, right? So technically, whatever I wrote right just now actually ran on it. You want to verify this further? So this is today's latest log stream. This is actually CloudWatch, and you can see that it actually ran, right? One thing that you will not see here is whatever you wrote in console log will not go up here because SSD just captured it and redirected it to my local terminal instead of CloudWatch. That's the only thing. But when you actually deploy, it will go to cloud. That's it. So this actually ran on AWS. So this means instant feedback cycle, right? I mean, this is pretty cool. All right, that's it. If you folks have more questions or if you want me to show you more stuff, I'll be happy to do that. All right, no questions. Yes, please. It is yes. So how they make money is they have a CI product. Uh, Called Seed. So that's how they make money. But it's all open source. It's pretty and they're open to contributions. Like I think 2 years ago, I helped them add Java support for Lambda. So they're open. And the cool thing is you can write your Lambda, whatever I just wrote, you can write it in most of the popular languages. They have packages for Go, Python. Uh, what else am I missing? That's it. Yeah, that covers. Yeah, Go and Python and Java as well. We should add that. So Seed is a nice little product which gives you CI/CD pipelines and preview environments on top of it. So you can install it on your GitHub and then have one PR, everything inside it deployed to a brand new environment. You can test it, stage it, everything. And then once you close the PR, Seed will take that, deploy it to prod, and then delete that, clean up that environment. This is how they make money. They've been very clear about building this open source. Any other questions? No. I mean, this was one example because I thought most people associate serverless with lambdas, but SSD lets you build pretty much everything you want. They have nice higher level functions like you saw API, right? And it gives you Lambda plus API gateway. And like that, they have crons, queues. They cover 99% of the most common use cases. But if you want to drop down and say, hey, I want to use glue, for example, right? Technically, you can just do ssd.cdk dot, and then you'll get everything in AWS. So you can technically write glue, you can set up provision infra, everything, and SSD will handle the actual cloud formation and then deploying and tracking that part. Now, tomorrow, if you delete code that had glue and you deploy, SSD will figure out that, okay, this stack is up for deletion and it will remove it from cloud formation. Normal Microsoft. Yeah, you can write that. So when you say microservices, you mean like where will that run? ECS? Yeah. Okay. So they have a cluster component. So they give you clustering out of the box, right? And the cool thing is when during development, they also default to nice defaults to make sure you save on cost. So when you write serverless, they will usually default to Aurora serverless, right? You have to opt in for RDS because RDS is expensive. RDS has a base cost, right? Brand new, I think it's $7 a month. So they'll default to all of the cheapest ones. They'll call it out in the documentation. You can opt in for the more specific stuff. So there's knobs you can turn for everything, but they come with good, sensible defaults. Yes, please. Okay. I will share a link with you where SST actually talks about this. Right? But I'll also give you a quick rundown of what happens here. So SST, um, what they do is as soon as you change code, because SST console is running locally, right, they will detect that okay, code is changed, right? And based on the compiled format. Now, for Node, it's just JS code, right? They will intelligently figure out if it's only 2 KB of change from a full 3 KB of file. They'll just send the full 3 KB file. How? Through AWS IoT. So AWS has this. So AWS IoT events is a default offering in AWS. And the cool thing is you don't have to pay anything for it. And every account comes with a default IoT endpoint. It gives you a low latency, high throughput WebSocket connection. What that means is you open a socket, you maintain a connection to AWS always. So AWS keeps it open. It's a multiplexed connection. So in that connection, they've they've detected that you've made 2 KBs worth of change. So they'll send it across, and the SSD on the other end has a CloudFormation stack that will receive this change, and it will apply immediately. So when you make that change while the application is stopped, when you say application is stopped, you mean SSD, right? Okay. 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 Yes. Depends. So if when you say the application is stopped, right? If the change was sent before the stop technically happened, it goes there. It is available on Lambda. Now let's say you stopped it before that change was sent, right? It's not sent. But when you restart, SSD will still take a checksum of what's on your computer, compare it with what's on Lambda, and it will still say that, hey, something new has happened here that is not available here. And then it will still send it. Yes. On productions, it will look very different. You would just do instead of so when I did npm uh, run dev, right? There's a SSD dev command. But really on production, you would just do deploy. Deploy it, you tag it, you send it, it's deployed, it's done. Nobody touches it unless you do a second deploy.
So the deploy is
Sorry. No, no. Okay, go ahead. I have no idea. I'll have to check. Oh, yeah. I, I'm sorry that you're working on .NET. The thing is, .NET is a very performant framework. C Sharp, F Sharp are amazing languages, but it's just most people, most teams, most organizations deprioritize .NET for some reason. Because honestly, you guys are a minority. I'm sorry.
so when you say we run the deploy, it will deploy.
Yeah.
Does that mean it's no more a dev environment, or will it be pushed to prod?
So you get to control that by default. Dev environment exists. Deploy is just sent to prod, right? But you can write logic. You can actually it's a configurable environment to say, hey, when I'm done, delete my dev environment.
Oh.
You can do that. Mm. Okay. It's just this. That's it. npm run deploy. That's it. Yes. Yeah. Yeah. So in your production environment, you just have npm run deploy. But in an actual real production environment, you would still have to do things like versioning, right? That stuff, if you want, you can build that yourself. Most teams end up building that, right? But if you want very specific stuff like developer A has done their changes, now they're deploying to main, and then that needs to go to deploy. But let's say developer B quickly makes another change. This too needs to be deployed, and I want specific versioning, things like that. That is where SST, their paid product, comes in. But I would say it's purely optional. You can go a long way without having to build that. What do you mean? No, AWS doesn't offer anything because the way AWS culturally operates is they give you the building blocks, everything that you need. It's up to you to build stuff. They take a very long time to build a meta product on top of something because it's not in their culture. You would also, it also makes sense for somebody like a cloud provider, right? Because you don't want to build too many abstractions on top of stuff. Because now, let's say you built a meta product, right? It's always somebody at your scale. There's always somebody that's going to say, "Hey, I want this. No, I want this. This is missing this one feature, small feature from the core product." Now then you're constantly just building everything. At one point, this becomes a replica of this, right? So by design, they rarely build meta products that are like wrappers on top of building blocks. They will always give you only the building blocks. That's why these problems, like these things, exist for solving 90%, 99% of the happy part. Any other questions? Yes, please. Good question. Uh, yeah, I mean, it's a little. This has nothing to do with SST, but this is, I think, still a useful question to ask. So, I'm sorry, I've not been repeating questions. Did everybody hear his question? Okay, all right, sounds good. So, how you do load testing is yes, there are teams who do load testing in production, but the things that they look for are different. The things that would show up in load testing is things like cold starts, things like that. Right? But I would say for 95% of the people out there, there's no need for a load test for for that. Yeah. Plus, it's battle tested. They've been around for a very long time. You know that they will scale. But we've run into some problems with load testing. I mean, we've detected problems. One of the most common things is you will hit your AWS quota limit. AWS by default comes with quota limits for everything. So you cannot suddenly go provision a million lambdas because AWS has safeguards to make sure that your account is not being abused. So you will have to contact AWS support and say, "Hey, this is me. I know what I'm doing. Give me more." Right. So these sort of quota limits exist for most teams. So that's how it's set up. But um, yeah, does that answer your question? Sure. Yeah. 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 So is your question? Uh, let me see if I understand your question. Right. So yes. Yes. Yeah. So that's a very good question. Um, so how cold? So it depends. Again, the short answer is depends. Why is I I would I would challenge teams that want to do load testing on lambdas to say, are cold starts really a problem for you? Right? I would say unless you've identified that that's a bottleneck for you, I would say don't bother, don't waste time, right? So there are ways to solve cold starts, right? For example, for Java JDK based applications, um, Lambda gives you this thing called snap start. It works with a very specific set of JDKs, but they basically get you a heap snapshot of the application. They run it once, take a heap snapshot, put it there, so that startup is fast because JDK applications traditionally struggle with startup problems, right? So they do have specific products for that. Another way, that traditional way everybody avoids cold starts, is they will uh, they will increase the concurrency, provision concurrency, to say from 1 to 2. Simple example, right? So that means AWS will always have lambdas warmed up and running for you. But that again will take us back to the EC2 problem, right? That means technically now you always have a lambda running, right? But that again, I would say, is it depends if you need it, right? Some people on your team might say, hey, at this point, why do I even need a lambda? I can just run on EC2, probably cheaper depending on the workload, right? So that's again, that's how I would say it depends. So then you take that call. I've seen this also happen. I've seen teams going back to EC2 because it was much too complicated, and cold starts are somewhat difficult to debug. It's improved recently, but it's a classic problem. So that sort of stuff always happens. Yeah. Yes, please. Two. Um, I'll be honest. This demo I built it in August for an internal talk. Since then, I think around December they've graduated to three. I did not have the time to rebuild this in three. Three is actually even more faster, and I briefly touched upon it when I said they've rewritten it in Pulumi and all. But thankfully, the APIs mostly remain the same. It's just you no longer have CDK, but you have Pulumi, which means you can technically build this on any framework, any cloud platform of your choice, because I think they already have like 100 plus providers. So if you're building on Alibaba Cloud, you can do this, which is actually good. Yes, actually, yeah, yeah. It's just I've not tested it. I've not run it on production V3, right? So I can't talk about it. Yeah, that's why I said I've never went into that, because that's all theory for me at this point. But yeah, SST3 solves this problem. They let you do multi-cloud, and you can actually. Oh yeah, so thanks for bringing that up. One of the coolest things is you can bind stuff cross-platform. So what happens is, in most teams you would end up, let's say, building AWS or Azure or whatever, but a lot of the teams would put Cloudflare in front of it because their DDoS product is unmatched. They would put Cloudflare in front of it, right? And this is one of the challenges that most teams face. So how do I say this is the cloud? This is where I'll take all of my AWS certificates to Cloudflare. I let them manage it, but I want them available in AWS as an imported certificate. It's a manual step, right? But SST makes this easy. They let you bind these two resources and say, hey, DNS and certificates are managed by Cloudflare. Do this. You can write code for all of this in one place and have this work, which is insane actually. I haven't updated the talk for SST3. It's a little new, so I've waited it around. They've rewritten the whole thing in Go because they are more productive in that, and they use Pulumi, so it's a brand new uh, part of the architecture. It's just I have not verified that in production, so I didn't want to talk about that. Yeah, and top on that list is CloudFormation. CloudFormation is very slow actually. Yeah. Yeah. Any other questions? All right. Thank you so much. This was fun because everybody had a lot of great questions. Thank you so much, and I hope you see you again in our next talks. Thank you.